Hello guys, and welcome back to Joe's Adventures, and today we're doing another episode of Jurassic World Evolution 2 Mod Spotlights, where we take a look at some of the wonderful mods people have been making and compare them to their real-life fossil counterparts. So today we've got a very interesting assortment of animals, really cool. So we've got a couple of remasters and a few new species, and we've got another Hawkow one, who's no one loving their mods, but yeah, we're going to be starting off with a bit of an interesting one. So what we've got here is a new feeder. So this is not just to do for... It just replaces the goat, but it has a new extinct animal I don't want to talk about. So here we've got Hyracotherium. Hyracotherium. Look at this one. This is Hyracotherium, which is a really cool animal. Let's have a look. Look at this little guy. I think you'll love this mod. This mod's by JWE2. Another really cool little mod. So this is Hyracotherium, which means Hyrax-like beast, even though it's not related to Hyraxes at all. It's an extinct genus of very small perissodactyl ungulates that was found in the London Clay Formation. These were a small fox-sized animal, and is for some scientists actually considered the earliest member of the family Equinidae, so the earliest horse, before the type species was reclassified as a paleothere. So it is still closely related to horses, but a little bit more basal, so it is related to both horses and the extinct Brontotheres. And the remaining species are now thought to belong to a different genus, including Eohippus, but they all have been previously synonymized or put under Hyracotherium. But yeah, cool bit of taxonomy. So Hyracotherium was actually about 78 centimeters, or about 2.5 feet in length, and weighed about 9 kilograms. Not much bigger than a cat. It had a short face with eye sockets in the middle, and a short stemma, which is the space between the front cheek and the cheek teeth. The skull, as you can see, is quite long, and they had 44 low crown teeth. Even though they are low crowned, these are the beginnings of the characteristics in their teeth, like modern horses with those long ridge-like molars, who are starting to believe. And this is believed to be because they had a much different diet. So much modern horses feed on grasses. These guys are much more browsing herbivores that eat soft leaves, but also nuts and shoots. So the first specimen was identified of this genus was the holotype found in Herney Bay near Kent, at the Stud Hill, by paleontologist Richard Owen in a paper that was described in 18 December 1939. So he identified it as an extinct group of the group Pachyderma, which included a bunch of different really weird animals, and then thought it looked like a Hyrax, so he called it Hyracotherium. And they thought it was a more like placoderm that was related to Hyraxes, and he called the new genus Hyracotherium lepidorum. And then they found a full skeleton of New Mexico, and then placed it under the genus Eohippus. And then the similarities are pointed out as well, and the only species Eogustidens was moved to the genus Hyracotherium, which had primarily of the genus because Eohippus was younger. So you typically in paleontology or taxonomy, the oldest genus gets a name first. That's why Basilosaurus is still considered Basilosaurus, because it's the first one. So it was considered that, and then a lot of them had been classified as early Pachyderm, and then kind of were taken out again, and now it's only just the one species. So they're now considered, as I mentioned, a paleothere, not a horse proper, and most other species of Hyracotherium are still regarded as equids and then replaced in other genera, such as like Protohippus, Eohippus, Areohippus, Diffohippus, things like that. So a lot of them have been lumped out of them. And at one time, Xenocohippus, which was another early horse, is actually considered an early Brontothere. And the mainstream of horse evolution seemed to begin in North America, which is really interesting because we don't have any horses in America anymore. So it's kind of like the same with camels. Horses and rhinos and camels kind of all evolved in North America, then spread out, and then became extinct in North America. So it's really interesting about evolution, things like that. But yeah, really cool. I love these guys. Definitely nice to see these guys, even though it's a feeder. Still cool to see a new species in there, so I thought that would be worthwhile showing off. JWE2 always does a great job with things like that. So you run off. Next up, We're going to have a look at this redone model. So this is done by Hyracotherium. So this is one we've already covered a couple times, but now it's got its feathers on it. So now Guanlong has its feathers on it. So let's have a look. This is really, really cool. And that bug always happens. And it's still happening. There we are. So here is Guanlong. So Guanlong is an extinct genus of Protoceratops dinosaur from the late Jurassic of China. It was first discovered in 2006 by Jisung et al. And was found to represent a new taxon related to T-Rex. So it's a really early relative of T-Rex. Its name comes from the Chinese crowned dragon, so Guanlong, crowned dragon, and 2 individuals are currently known with a partially complete adult and a nearly complete juvenile, and these guys came from the Oxfordian stage, or late Jurassic, of the Chinese Century Formation. As mentioned, described in 2006, the word means Guanlong, crowned dragon, and the specific epithet, the species is Wukai, which means multicolored or 5-bay colored, because that refers to the multicolored rocks it was found in. And at present, as I mentioned, only known from 2 specimens, on top of with other 3 individuals found. The holotype is reasonably complete, partially articulated adult, and the paratype is an immature specimen, but is nearly complete, and it was thought to be trampled to death by the actual adult. And the crest on the skull is notably smaller, so it seems like this is definitely something that grew with age, which is quite interesting. And those also suggest, as I mentioned, they may have likely had this crest potentially as a mating display or something like that, or something to show age. And these guys, unlike T-Rex, no, not an absolutely massive theropod, these guys reached about 3 to 3.5 meters, or about 9 to 11 feet, and about 125 kilograms, so quite a decent sized animal, but about as big as a person, a large person. Its fossils was found in the Hyracotherium Formation dating to about 160 million years ago, in the Oxfordian stage, so this was 92 million years before its later relative T-Rex was around. And it shares many traits with its descendants, unlike though it has 3 fingers, unlike most Tyrannosaurs having 2, and also it has a crest, which is very interesting. It looks like Tanglong, and Tanglong might have had feathers, so Guanlong most likely had feathers as well. So in terms of its grouping, Guanlong is seemed to have clade with both Protoceratops and Koolasuchus, which form the group Proceratosauridae, and includes a bunch of really early Tyrannosaur relatives, things like Sinotyrannus, Junotyrant, and Stoxosaurus from America. However, in 2014 it was found that Stoxosaurus and Junotyrant are just outside that group, and then the true group of Proceratosauridae is Sinotyrannus, Koolasuchus, Guanlong, and Proceratosaurus, which is quite cool. So what's really cool about the 2 specimens that we have have done a historical analysis, so we do know how old they are. So the adult was showed to mature at about 7 years of age and died at about 12 years old. And the juvenile was about 6 when it died, and it was still growing. And these individuals, different ages, so they can actually track the changes in the crest as a group. And it seems that the younger one had much more restricted crest than the snout, and it's proportionally shorter, and then it got bigger, much bigger, and extended up the snout as it grew. And it seems this would have been, something for display. It also seems to be highly pneumatized, similar to those of Dilophosaurus and Monolophosaurus. So very, very much full of air, or something like a cask, like a cassowary. They would have been more open and allowed them for maybe more display. It wouldn't actually be like fighting or anything with them, which is quite interesting. But yeah, we're going to let them go off and do their thing. We can see, as we mentioned, last time it didn't have the fur, but now it has a fur on it with the fur shader. Looks really, really awesome. I love seeing the nice texture of it. That was one of the best things to come to JWE, was that bloody fur shader. It looks so awesome. Or feather shader should be technically. So I'm going to let you run off and do your thing. So next up, this is also done by Hyracotherium. We've got everyone's favourite saurian player animal. We've got Dakotaraptor. Here we've got Dakotaraptor. So let's have a look at one that's not looking funky. We'll have a look at you. You look like the best position. Right. So this is Dakotaraptor. So Dakotaraptor means a thief from Dakota, is a potentially chimeric Maniraptor theropod dinosaur that lived in western North America during the late Cretaceous. Its remains have been found in the Maastrichtian Age Owl Creek Formation and dated to the very end of the Mesozoic, and making Dakotaraptor potentially one of the last surviving dromaeosaurs, even though there are researchers that are kind of not sure of that classification, as parts of the holotype may have referred to being found to belong to turtles, and others are unsure about the divinities and they can't be properly concluded. So these we really don't have a good idea, and we can't get a good idea because the specimen is housed in a private collection, which is interesting. So yeah, in 2005, Robert De Palma was found a blown bed with a variety of dinosaur and non-dinosaur remains, and found partial skeleton of a large dromaeosaurid. And then in 2015, the type species Dakotaraptor steni was described by a bunch of people like Robert De Palma, David A. Burnham, a bunch of P. Larson, and Robert Thomas Barker, with the genus name Dakotaraptor referring to South Dakota, where it was found, and raptor meaning plunderer, so it's Dakota plunderer. And it was actually one of the 18 dinosaur taxa described in 2015, and it was open access and free to read. So the holotype was found in sandstone layers of the Upper Howell Creek in the late Maastrichtian, and it contains a partial skeleton of an adult without a skull. It has like back vertebrae, tail vertebrae, humeri, radius ulna, things like that, bunch of cool bones. And apart from the remains of the holotype, it seems to have belonged to. It was also discovered of a Rotoraptor which seemed a more gracile morph, so it may have been one thick one, one thin one, you could say. And some other little bits have been found as well. And the elements originally found as the furcula was like U or V shape, which was actually similar to many other dromaeosaurs and even the large spinosaurs like Suchomimus. And then it was proposed that the furcula was actually part of a turtle armor, which is the entoplastron of a species called Axostemus splendida, which is a soft-shell turtle. And in 2016, recognized that none of the recognized furcula actually found them at all. In 2024, even the dinosaur elements of Dakotaraptor were questions, with dinoxy traits seeming to belong to things of large ornithomimids and catharinids, or like things like Anzu. So it may not even be a thing at all. It's a dubious genus. We just can't clarify, really. But still a cool design. We'll have a look. So Dakotaraptor was actually quite large for a dromaeosaurid, with an estimated adult length of about 5.5 meters, or about 18 feet. So about the same size as Jurassic Park, not T-Rex, Velociraptors. In 2016, though, those estimates suggested a length of 4.35 to 6 meters and about 220 to 350 kilograms. So it approaches like size of Dakotaraptor and Achillobeta. However, it did not have proportions like them. It had proportions much more like Deinonychus, so it's much more like the Jurassic Park Velociraptors. So it does have a few interesting traits and things like that, and like other things, it was highly pneumatized, so it would have had a light skeleton to be able to run. And being flightless, they do have wings very similar to things like they were more anatomically much similar to things like Deinonychus potentially, and we'll get into some of the taxonomy and things will go on. And we do have a good idea of potentially like pursuit predator, things like that. In terms of its classification, as I mentioned, it is a little bit smaller than like things like Achillobeta and Utahraptor, but it's a place in Dromaeosauridae and is said to be sister with Dromaeosaurus. And then it formed a clade along with Utahraptor and Achillobeta, which is very interesting, which is, despite being related to these large dromaeosaurs, they suggest there was a separate fourth instance of dromaeosaurid size increase, which is besides the Deinonychus, Unulagia, and the Achillobeta plus Utahraptor clade. And there was even a recent study they looked into recently, about 2019, that suggested these guys were Unulagine. So they would have been the northernmost Unulagine genera, and they would be related to things like Unulagia, Rahadnavis, Buenoraptor, Pyroraptor, things like that. And even another one suggested they would have been a basal dromaeosaur. But it's kind of something that's been going back and forth. And there has even been some talk that potentially Archaeoraptor, which is like the North American Maastrichtian version of Velociraptor, may have been synonymized with the same thing. There's a lot of teeth that overlap, and they're known from individuals of different sizes, with some smaller that are also fully mature. So it seems that could just be a large, Archaeoraptor. And plus it being chimeric and everything is not going to be helpful for its case at all. But interesting. But very much like other Dromaeosaurs, it had that large sickle claw, which was used to bring down prey, and had a more robust flexor tubercle than that of Utahraptor. But on the contrary, its third foot claw was actually smaller in size than the Dromaeosaurs, so it may not have been that important for attacking prey. And there seems to be two kind of morphs, a robust and a gracile one, were present in the fossil materials that suggest these both morphs were adults, but the lighter build of some bones were not caused by young age. Instead, this could be something like sexual dimorphism, which is particularly small individuals, but there's no way to prove which one was male or female. And there was also quill knobs found in the ulna of the lower arm on these guys, so suggests they would have had large feathers, very much like typical other dromaeosaurs and birds, but they would not have been able to fly, simply being way too heavy. But they could have potentially used these wings for display and intimidation, or potentially like to keep balance and things like that. So it's very interesting that they still had those big wings, even though they couldn't fly. And I almost don't need to really talk about the Hell Creek Formation, so it's the first medium-sized predator found from the Hell Creek, aside from Nenotyrannus, but it's not really to get to that. It was kind of intermediate between Archaeoraptor and Tyrannosaurus, so it's kind of that mid-level pursuit predator, kind of like your leopard kind of thing. And these guys are suggested to be quite a pursuit predator, and potentially could have been a pack hunter and hunted in groups, but we really can't tell. They could have preyed on animals and larger herbivores, and potentially even subadult tyrannosaurs. And they've been found alongside lots of really famous animals. I was mentioned things like Brachycephalosaurus, Ornithomimus, Triceratops, Tyrannosaurus, and Entomopterosaurus. So a very, very interesting habitat there. And I'm going to say Hyracotherium did do a good job of giving us this cool guy, because I do like the patterns it's got. Very Saurian inspired, because that's probably the most famous version. But yeah, it still looks really, really good. I'm definitely a big fan. So I'll let you run off and do your thing. So next up, we have got Koolasuchus, also done by Hyracotherium. But this is a very cool guy, if I do say so myself. Oh, that's not where we wanted. We'll have a look at one that's kind of not in the grass yet. We'll have a look at you. Look at how pretty you are. So this is Koolasuchus. So Koolasuchus is an extinct genus of brachiopoid temnospondyle in the family Chisingosauridae, and fossils have been found from Victoria, Australia, and date back to about 125 to 120 million years ago of the Barrian-Aptian age of the early Cretaceous. And this makes Koolasuchus very interesting because it is the youngest known temnospondyle and is known from plenty of fragments in the skull and other bones such as ribs, vertebrae, and pectoral elements. And the type species Koolasuchus keelandi was named in 1997, and then it was adopted as the fossil emblem of Victoria, Australia in the 13th of January 2022. So this one's, of course, very famous for being on Walking with Dinosaurs. So the first fossil of these guys were found in the Shirzalaki group, and it was as a posterior fragment found in the 1980s. Then a jaw fragment was found in 1986 by Annie Warren and R. Job, who did not actually identify it as a temnospondyle due to its Cretaceous age, since there was not many temnospondyls in the Cretaceous. Then in 1991, there was another one found, part of a vertebrae, an isolated skull roof was also found, and it suggested these guys are a temnospondyle. If I remember, Plateosauridae are brachypodidae. And then it was named in 1997 from the Aptian and Wulgarthi formations in the Cetacea group of Victoria, and is known from quite a few different elements, including furcular and the jawbone was actually found in 1978 in a fossil site known as Punch Bowl, near the town of San Remo, and later specimens were found in 1989 near Rowles Beach, and the partial skull has also known but not fully prepared. And Koolasuchus was named after paleontologist Leslie Cool, and the name was a pun to refer to cool as in the cool climate of his environment. And then the type species Clearlandi was named after geologist Mike Cleland, so it's named after two quite important Australian paleontologists. So you can see Koolasuchus was quite large. It was an aquatic temnospondyle, so a giant group of ancient amphibians. It was like a giant crocodile salamander is probably the best way to describe it. It got up to about 3 meters long and weighed about 500 kilograms. And like other chanid forms, it had a very, very wide rounded head, as you can see there, and tabular horns projecting from the back of the skull, so you can kind of see that there. Although it's incomplete material, the skull was likely about 26 inches or 65 centimeters long. And Koolasuchus is also kind of distinguishable, aside from things like Stinrops and Hyracotherium, is having the ramus on the mandible, which is quite different, so there's another way to tell it apart from relatives. But very interestingly is where this guy was found. So inhabited the rift valleys of southern Australia during the early Cretaceous, and this would have been when Australia was in the Arctic Circle, so temperatures would have been relatively cool. And based on the coarse graded rivers where it was found, it likely lived in fast-moving streams, and as a large aquatic predator would have lived very similar to crocodilians. And although crocodilians and their relatives were definitely around and common during the early Cretaceous, they was thought to be absent in Australia about 120 million years ago because of the cool climate. But by 110 million years ago, the rocks of this area had warmed, and crocodilians may have come to this area, and it suggests that these crocodiles may have displaced Koolasuchus, and it seemed to have disappeared in younger rocks. So this guy might have just been this little guy holding out in the coolness of Australia until crocodiles came back and took over. But yeah, it's still a really cool animal, and it's a really cool example of how animals is a bit of a Lazarus taxon. Great example of them. So they've been disappeared for the fossil record for ages, and then just pop up randomly. But yeah, really, really cool, and I love the colours. Sasquatch Tree really did a wonderful job with this guy. Definitely, 100%. So let you all run off and do your thing. So now we've done with all the Sasquatch Tree stuff. Next up, we've got one by Master Dude. We're going to have a look. So this is Tanglong. This is a cool guy, isn't it? Alright, just gotta wait for it to stop being fugly. Let's have a look. Let's have a look at this guy. So this is the Tanglong. So this is extinct genus of theropod that's believed to be either a Carodontosaurid or a megalosaur. Here it's been obviously reconstructed as a very megalosaur. It existed during the early Cretaceous or Barrian Aptian of what is now southeastern China, So in 2011, the staff of the Geological Survey Research Institute at the village of Nauzhou, 20 kilometers southwest of the town of Datang, near Nanning in Guangxi. I believe you say that. I'm not going to be forgiving my pronunciation because it's probably terrible. But they discovered the remains of a large theropod new to science, and then named it 2014 as the Tanglong guanensis, which name kind of combines to be the Datang Bansen, so it's the Datang dragon, and the specific name runs to the province of Guanxi. So it's only known from the one specimen, which has vertebrae and hip bones, and it's kind of known from lip pubis bones, so not really too much diagnostic traits. And the bones were found in the Tanglong Formation, which was deposited sometime during the early Cretaceous. So it's potentially quite a large theropod, probably about 8 to 9 meters, so kind of mid-sized range, but was still quite big. And the specimen is preserved as about 3 feet, so there's not a lot of it actually preserved. And there's some very interesting characteristics. And its last dorsal vertebrae actually looks like something like a ceratosaur, so it seems like a very interesting kind of hodgepodge of features. But when it was first described, it was placed in the Caroodontosauridae in quite a basal position as well. And then soon after this, Andrew Cow pointed out it looks much more like basal tentoneuron, or like three-fingered, and would have contained a few traits of the Coelurosaurs, which includes things like T-Rex and ornithomimosaurs and things like that. And if this is correct, this is the first known basal Coelurosaur of quite large size. And it was also directed the attention that all the synapomorphies that shared with Caroodontosauridae were actually shared with Megaraptorans, so it's actually potential that this was a Megaraptoran as well. So it's most likely that Datang is actually, Datanglong is actually Megaraptor, but with such scant fossils, you really can't know. It's one of those things that you just don't know, and we probably won't know until we find more. But yeah, really, really cool, nice interpretation. I really love like the quill knobs going on there on the back there as well. Gives it a more distinct look, I think. Definitely a big fan. And obviously, Master Dude always does a great job with their mods. And they're always pumping out some rather great ones. Okay, so we're going to let them run off and do their thing now. So that's the Tanglong. Now it's the Tanglong. So next up, we're going to have a look. This one's done by Netraptor, Trippy, and Gojira Chief. We have got Electrosaurus. Here it is. Here's Electrosaurus. So we can find one in a good. Oh, you look cool. I like that posture. Let's have a look at you. So this is Electrosaurus, which means a lone lizard. Tragic. Is a genus of Tyrannosaurid dinosaur that lived in Asia during the late Cretaceous from about 96 million years ago, which is now the Iron Dabusu Formation. So in 1923, so the third Asiatic expedition of the American Museum of Natural History, led by paleontologist Walter G. Gardner, was actually hunting for dinosaurs in Mongolia. And then on April 25th in the Gobi, assistant paleontologist George Olson discovered this specimen. And it was a nearly complete hind limb, including the virtually complete right hind limb as well, with some elements of the left pes and the two manual uncles. So kind of other little bones there, some digits there. And there were some bits of unspecified elements that were discarded that were due to bad preservation. And as I mentioned, these discoveries were made in the Iron Dabusu Formation, which is now considered the Inner Mongolian Autonomous Region of China. And both genus and species were described by the American paleontologist Charles Gilmore in 1933, with the generic name meaning Electrosaurus being like a lone lizard or mateless lizard. This is derived from the Greek word, electos, which means unmarried, and when it is a lizard, saurus means lizard. And the specific name, Olsony, derives George Olson, who discovered the specimen. And there have been potentially some more material found. 2 other potential specimens have been found, with partial maxilla, things like that, and found in Outer Mongolia. And then there's some that have been believed to be from Campanian Maastrichtian age, and then could be belong to Namek Formation, which is quite interesting. In terms of the lectotype is quite fragmentary, and there's a few elements. But in terms of what we know about it, seems to be like a medium-sized tyrannosaur, reaching about 5 to 6 meters long and weighing about 454 to 907 kilograms, so just under a ton at maximum. And its hind limbs are actually quite gracile compared to more robust tyrannosaurs, and the length of its tibia and fibia are very close, in contrast to many of the tyrannosaurs, which the tibia was typically longer, which is very interesting. It has some very interesting features. It's got some, I'm not going to go into much of those, it's very anatomically nitpicky, but it's quite interesting. So we're looking at the classification of these guys. So looking at the material, and they suggested they were more similar to like a Gorgosaurus, and he classified the new genus as Dentrodont, a Dinodont, you could say, like dinosaur, and is equivalent to a Tyrannosaur. And was originally classified as a long-eared theropod, and then in 1989 was found the forelimb actually was suggested to be more real closely related to Tyrannosaurus. And this caudal vertebrae of this theropod was not actually suggested to be similar to Tyrannosauria, Therizinosaurus, and actually showed resemblance to Deinonychus and Deinonychus and Plateosaurus. But the most 2013 study actually suggests that this guy was actually a Dryptosaurid, so related to animals like Appalachiosaurus, Dryptosaurus, and Zingong Guanlong, which is very interesting. Kind of a really basal tyrannosaur, kind of in the middle between Tyrannosauridae and things like Tyrannosauria, but not in Proceratosauria at all. So what's really interesting as well is the hind limbs are quite long and different from other tyrannosaurs, and actually these traits are very found in terrestrial running birds, so these guys were quite a fast running tyrannosaurs, potentially being a pursuit predator, and these finds are consistent in observation level proportions, so it seems like these guys would have been most tyrannosaurs were mostly leggy animals and highly cursorial, with the exception of things like Tarbosaurus and Rhinoceros, but these guys would have been able to run quite fast and things like that, which is quite cool. But the formation it lived with was quite interesting as well. So it's dated to the Cenomanian, about 95.8 million years ago. And at this time, there would have been a large floodplain with extensive vegetation and lots of large herbivores as well. Animals that it would have lived with includes Archaeornithomimus, Elandosaurus, Gigantoraptor, Nemectosaurus, Ceratosaurus, Gilmosaurus, Bactosaurus, and likely would have preyed on them as well. And then there was another one found in the Bayesian Sea Formation that includes animals like Ichthyovenator, Glandromimus, Shignosaurus, Talirurus, Protoceratops, Globihedros, and Euchrid, and things like that. So quite interesting. It would have had an interesting formation. And very interesting animals it would have lived with. Yeah, really, really cool. How can you not love this guy? And I think Netraptor and Trippy and Gojira Chief really did a great job. And look, we got all the feathers. How can you not love the feathers? And some nice patterns too. Definitely came out rather nicely, and I like that red eye. I think it gives it like an interesting, distinct look to it. Yeah, really, really nice. So I'll carry on. So you run off and do your thing. So next up, we've got a Sweetener mod. So this is done by Sweetener and Trip. Nice to see them again. So we've got Ichthyovenator. Come on, it does it again. And here we've got Ichthyovenator. We'll have a look at this one because it's like probably no, we'll have a look at this one. This one looks a little bit nicer. We'll have a look at you. I kind of like the darker color on this one. So this is Ichthyovenator. So these guys are a genus of Spinosaurid dinosaur that lived in what is now Laos between 125 and 113 million years ago, about the Aptian stage of the Cretaceous. And it's known from fossils from the Eurosupremus Formation of the Savannah-Kurt Formation, which was first found in 2010, consisting of a partial skeleton without the skull or limbs. And the specimen that became the holotype of this new genus is Ichthyovenator laosensis, described by paleontologist Roman Alan in 2012, and its generic name means fish hunter, since it was assumed because it's a Spinosaur, very piscivorous lifestyle. And then a specific name refers to Laos, where it was found, which is interesting as well. So, as a holotype specimen is estimated to be about 8.5 to 10 meters long, or about 28 to 34 feet, and would have weighed about 2.4 tons. And they had teeth that were straight and conical, very similar to other Spinosaurids, but actually quite similar to Sigomastosaurus. And like many of the others in the family, it had torneural spines and had a wave-like kind of sail going down, which is quite interesting. Also looked like it had two separate sails. The pelvic girdle was also reduced, and the ilium had both parts of the pelvis were proportionally longer than both the pubis and ischium, like other known theropods. And they were initially thought to be in the family Baryonychines, so more closely related to animals like baryonyx, but that suggested these are actually a quite primitive member of the Spinosaurid family, so related to Spinosaurus, or Spinosauridae. It was quite interesting. As I mentioned, the first fossils were found in 2010, and they were found in Laos, where they were recovered from a red sandstone layer with a surface of less than 2 meters, and they found quite a bit of it. The holotype specimen was kind of found with the sail and the hip, and these other described, like the undescribed stuff like the neck and tail vertebrae, which is quite interesting. It suggested it had a bit of a sail, very much like modern Spinosaurus interpretations on the tail, like a fluke. As already mentioned, the type, species, and name, and it's very likely a Spinosaurid dinosaur. And it was the third named Spinosaurid dinosaur from Asia after the genus Cymosaurus and the Chinese species of Spinoposaurus, which may actually be the same animal as Cymosaurus, which is interesting. And they noted the vertebrae with undescribed specimens of this animal was very similar to Sigomastosaurus, so it tells you a little bit more about these guys. So we've already gone to the size. Their teeth were very conical and straight, very similar to other Spinosaurids, and like many other dinosaurs, it had that sail, which is quite interesting. In terms of its classification, as I mentioned, it was originally considered a baryonychine and quite basal, so closely related to things like baryonyx and Suchomimus. but then it was found in 2015 that were more likely distinguished as kind of either in between, or they actually found they were more closely related to things like Irritator and Ichthyovenator, so more basal to the Spinosaurian group. So its most closest relatives at the moment is considered things to be like Irritator and Simosaurus, which makes sense. Simosaurus is from Asia as well. But in terms of its paleoecology, wouldn't have been too similar from other Spinosaurs and may have been lived a little more like crocodilians. Considering its long snout, they would have potentially eating a lot of fish, but also there has been Spinosaurids found with bones of pterosaurs and sauropods in them, so they most likely would have just eaten whatever, really. And the sails is something that's always been on about this. Things like thermoregulation or energy storage, but most recent things may have been like display, especially like sexual selection as well. And like other Spinosaurids, they may have had semi-aquatic lifestyles. How aquatic, we really don't know, but they would have been able to live in these kind of river habitats or coastal habitats to be able to swim and be able to grab fish like that way. So in terms of its paleoecology, as mentioned, is from the Aptian stage of the early Cretaceous, so about 125 to 130 million years ago, and lived with other types of dinosaurs like the sauropod Dinosaurs, but also another intermediate sauropod, Iguanodontians, Neoceratopsians. Also, sauropod and orthopod dinosaurs have been found, and lots of species of fish and turtles have been found, which all would have been pretty good prey for these guys. But yeah, really cool Ichthyovenator. Really, really cool. Love Sweeteners coming back to modding. It looks so awesome. Definitely a big fan. How can you not love this guy? Really, really cool. So yeah, we're going to let them run off and do their thing. I think we'll have to round them up first because I want to have a look at the new animal. I don't want them running and interfering. So let's quickly do that. Okay, so we're back. So now we've got another mod. This is done by Harkel1215, an animal that's been requested for a long while. We have got Protoceratops. Let's have a look at these wonderful guys. Let's pick one to look at. I want to get one with a nice colour. I mean, they've all got kind of nice colours. This one. Let's pick you. We'll pick you. I like this colour of this one. As I mentioned, this is Protoceratops, which means first horn face. So these guys are a genus of small Proceratopsid dinosaur that lived in Asia during the late Cretaceous, so about 75 to 71 million years ago. So these are two species in this genus. The first one we're looking at is Andrewsii. This does come with both species, and the other species is P. Helenocorhynchus, which we'll get into soon. And the first species was described in 1923 from fossils from the modern Jurassic Formation, and the latter was described a little bit later from the Basin-Mundu Formation. And Protoceratops was actually believed to be the ancestor of Ankylosaurs and larger ceratopsians such as Triceratops and relatives until the discovery of other Proceratopsids such as like Bagaceratops as well. These guys are quite cool. We'll go about the history of the discovery. We'll start and then we'll look at the other species and talk about the differences and keep going. So 1900, Henry Fairfield Osborn kind of made his way to Central Asia to look for the origin of most animal species, including human, and kind of went with the expedition explorer and zoologist Roy Chapman Andrews, and they went to Mongolia, and with different expeditions, as we kind of alluded to before, under the direction of Osborn, and led with the field expedition led by Andrews. So we kind of went around looking for different areas to find fossils. In 1923, they looked around the Flaming Cliffs, and they found even more specimens of this Protoceratops after they found the ones, as I mentioned, on September 2nd, they found the holotype, and then they found more. And they found the first remains of animals such as Velociraptor, Ornithoroides, and Oviraptor, and also found the first fossilized egg, which was near the holotype of Oviraptor, and given to how abundant Protoceratops was, it was said to be that taxa. And funny enough, Oviraptor got its name Egg Thief because it was thought to be stealing Protoceratops eggs, but actually it was sitting on its own eggs, so it's kind of, things like that. So in the same year, they described that new species of genus of Protoceratops andrewsoni, which is based on the holotype skull, and the name Andrewsii is named by Andrews, who led the expedition. They identified it as an ornithischian, closely related to ceratopsians, and potentially an early relative of Ankylosaurs and ceratopsians. And since Protoceratops is more primitive than any other ceratopsian known, it was in its own species Protoceratopsidae, which was mostly characteristic by its lack of horns. And although not stating the original description, the generic name Protoceratops intended to mean first horned face, as it was believed that Protoceratops was an early ancestor of ceratopsians. And they actually noticed the importance of this find, and the genus was held as a long-sword ancestor of Triceratops, and was actually quite well preserved as well. And then they found more and more specimens, including eggs and nests of the species, so we know the species quite well. And then keep going, there's more partial skulls, things like that. And as I mentioned, there's 2 different species. A lot of them had been named new species and then lumped and put in their own genus, own genera, such as Bravoceratops and Bagaceratops. But now there's only considered to be 2 species, as I mentioned, Andrewsii and Hyracotherium. It's quite cool. We do have lots of eggs that belong to Protoceratops, so we have fossilized embryo within them as well. Overrapted embryo, what's actually suggested to be like them as well, but we don't really have this kind of nest, I don't believe. They were thought to be Protoceratops eggs, but it was actually believed to be that we do have hatchlings and things like that, which is quite cool. So the part of the third expedition, they found the first fossilized eggs, and they were thought to be, because of Protoceratops being quite common, they thought to be the same species. And they actually have been looking into research and actually suggesting that it's actually Oviraptor, and the species may have had kind of soft-shelled eggs, very interestingly. But there was an authentic nest found, and they had about 12 eggs and embryos, with only 6 embryos preserved near the complete skeletons. And then it correlates as well. These guys definitely had the soft shells. So unlike a lot of other dinosaurs like sauropods and theropods that had hard shells, potentially a lot of ornithischians had soft shells, excluding hadrosaurs. So it may have been something that a lot of animals may have had, may not have, which is quite interesting. And the fighting dinosaurs, which is quite interesting. They found preserved fighting a Protoceratops was found fighting a Velociraptor, which is quite interesting. And there's also great skin impressions that have been found, possible skin impressions that show the kind of skin that they had, and which is quite cool. But sadly, a lot of it was actually destroyed. But we're going to move on to the description. Protoceratops was relatively small for ceratopsian sizes. They got to about 2 to 2.5 meters and about 62 to 104 kilograms, or about 6 to 8 feet long, and between 137 and 299 pounds. And even though they're quite similar in size, the 2 species can be differentiated by their skull. So you can see that the skull of Andrewsoni, so you can see it's got like a very different skull. We'll have a look at Hyracotherium as well. So as I mentioned, the skull is relatively large compared to the body and quite robust. The skull-type specimen had an average length of about 50 centimeters. On the other hand, the other Hyracotherium was actually about 70 centimeters, so slightly bigger skull, even though they were about the same size, which is quite interesting. And he also has these big jaws, very characteristic of ceratopsians for chopping down on plants and things like that. But they didn't have those horns, which was quite interesting. So they didn't have the horns. They did have ceratopsian face, but they hadn't quite developed those horns yet. The vertebral column is very interesting as well. As you can see, they've got a very interesting vertebrae, and you can see the caudal vertebrae as well. So they have like this kind of going around, a little bit of a sail going on their tail there. So they had a little sail-like structure, which is quite interesting. And in terms of classification, it was placed, as I mentioned, in the new family Protoceratopsidae. But furthermore, analyses kind of more recently suggests is still on Protoceratopsidae, but it's related to things like Bagaceratops, which was originally considered to be Protoceratops. And there are other genera as well, like Globoceratops, Lamboceratops, and things like that, were long considered distinct and somewhere placed, and then they're found to be in their own group. So Protoceratopsidae today represents Bravoceratops, Bagaceratops, and Protoceratops, which is interesting. And in terms of its evolution, there is some evidence of evolution there. So they indicated that Hyracotherium had actually high morphology when compared to highly derived morphology when compared to the Andrewsoni. That actually suggests that may have been like a lineage So Protoceratops may have been actually have evolutionary history compared to P. amazoni, and then obviously just different things like that, or simply a direct descendant. And the differences in morphology suggest that Protoceratops may have actually suggest that the Baharamana formation is actually slightly younger. And then 2020, they actually found several long undescribed specimens that were a trait that were kind of intermediate between Bagaceratops and Andrewsoni. So it kind of actually found that these may have been potentially either anagenesis or Protoceratops andrewsoni evolved into Bagaceratops, or hybridization between two species, things like that. So very interesting kind of figure out where their evolution lies. And it's cool that we have enough specimens of these animals to kind of figure out that where that is. You can have a great look. So this is andrewsoni. You can see that difference there. Kind of taller skull, not quite as big skull as well, much wider frill. It seems much rounder. But yeah, we'll let these guys run off and do their thing. And then we'll we'll grab the other species and talk about more their kind of biology, things like that. But yeah, we're just going to watch them do their social animations right now. They just want to hang out in front of everyone. Might be quite cool to do like a more direct comparison, so we'll see if we can get them to release. See, this is Hyracotherium, as we mentioned, so let's have a look at these guys. So you can see, you can actually kind of directly compare them a little bit. So you can see these guys have got much like a wider but like more less rounded skull, more like differently shaped. These guys are a lot rounder, not quite as big robust heads, but you kind of see the difference there. It looks a little bit actually more like a Bagaceratops, which is quite interesting. So it could have been anagenesis. So looking at the species in terms of what they would be eating, there's been a lot of research to that. So looking at the overall shapes and jaw musculature, it suggests these guys would have had big muscles, potentially to basically being able to bite through things. And the enamel shape does not actually relate to the diet and function of animals. So these would have had dental batteries very similar that would have been able to chop up leaves. And then in 1991, Gregorius Paul actually contrasted these guys may have been herbivores and actually could have been meat eaters, very similar to things like pigs, hogs, and boars, and would have scavenged, which is potentially possible. They do have big jaws, and often herbivorous animals will eat meat from time to time, but whether it was like a meaningful part of their diet is pretty much like no. But most recent evidence suggests that these guys would have been herbivores and potentially eat fruits and seed materials, and they would have never been available to them. And some little bit of research looking into ornithischians as a whole actually suggested that herbivory and non-avian dinosaurs actually evolved multiple times, which is quite interesting. So ceratopsians, and there was like two types of skull types. It was either ones that had low bite forces or high bite forces, and like robust jaws, or some that had like gracile skulls but not strong bite forces. But ceratopsians, along with Eupocephalus and Parkosaurus, things like that, were found to be in the former, reaching these guys had a relatively strong bite force and then relied mostly on their jaws to process food, so they wouldn't have had quite the guts maybe some other animals had, and they would have used their jaws a lot more to break things apart. And we also have quite an excellent idea of how these guys grew, which is quite interesting. So we know kind of how they grew, and we actually have the development of two nasal horns in P. Hyracotherium. It actually suggests that may have been a trait that's a sexually dimorphic trait, and this is based on the fact that one small specimen had a skull slightly smaller than a presumably sexually mature and lacks the double kind of mature horns. So it's very much suggested that it could have been the sexual dimorphism, but it seems more likely that they were different species. But looking at the historical analysis, they kind of looked at several specimens of Protoceratops and looked at how they grew, and they indicated they slowed down their growth at about 9 to 10 years old and ceased it at all at about 11 to 13 years. And they observed the maximum or latest development of the neck frill and nasal horns of oldest individuals of Protoceratops, and suggested that the maximum radial frill and things were present in most adult individuals, and trying to differentiate sexual dimorphism in Protoceratops was not a good idea because it's so hard to tell, and there's not really a good way to tell male and female dinosaurs apart, other than potentially medullary bone, but that's not always, steadfast. But yeah, that's a great example of the two different ones. Pose it like that, and you just get a good example of the different skulls there. David Horn as well looked at the neck frills as well, and found that their Protoceratops had smaller frills of juveniles and then grew at a rapid rate and reached a considerable size only in adulthood. That suggests that may have been something to kind of be a part of adulthood, maybe for something signaling, which is quite interesting. Or maybe they just needed it more in adulthood for whatever reason. Very much similar traits with things like Triceratops as well. And there's also some things looking at several specimens, bone histology, to see how the dinosaurs grew, and then they took lots of different parts of the body, and they would have had large abundance of bone fibers, things like that, and they would have shown that these guys had a growth rate more similar to other small herbivorous dinosaurs like Scutosaurus and Psittacosaurus. And I was a little bit wondering, 1996 they thought they would have been a most likely oglegate but there'd been some people looking around whether it would have been biped or not, which is quite interesting. Looking at the analysis of the forelimbs, they suggest the hands could reach out to the ground, so they suggest they were facultative biped, or pretty much mostly a biped, and also looked at his footprint suggesting it was digitigrade as well, so it walked on its digits and not on its palm like we do, or like bears do. And there's some evidence of things like digging behaviour, so they actually may propose these guys would have been digging and using their strong muscles, especially the camera to dig with their legs as well. And they suggest that it may have been good for digging, potentially good for like burrows, or potentially either burrows or nests, and they could have done both, it's not out of the question. And in terms of tail functioning, there was actually some suggestions because of that taller tail that they may have been partially aquatic because of those tall tails, very much like like a crocodile, be able to use them to swim. But then they looked in the high neural spines of things like desert lizards and suggested it may have been actually much better to store fat, and that where most reptiles store their fat is in their tails. They potentially would have used it as well. And plus they lived in a desert, so being the best swimmer is probably not the best adaptation for living in a desert. But there was also some evidence of Protoceratops living in fluvial deposits as well, kind of mixing the hypothesis as well, but it seems these guys would have most likely not been very aquatic at all, that we really just can't have evidence to move it out. And there is relatives such as Leptoceratops and Montanoceratops, which would have lived, and Koreaceratops as well. That's thought to have believed to be a little bit more aquatic, but we really just don't know, and there's no way to tell. And there had been the most recent studies suggest they would have had a swimming adaptation would be useful for avoiding aquatic predators, such as crocodile morphs. So they may have been kind of a little bit more hippo-like if they were aquatic, but nothing really interesting in that way. And social behavior, there has been some groups or monophyletic or species only bone beds found. So there's some medium-sized to adult-sized Protoceratops of Andersoni found, and they've been forming herds and varied in composition. And these herds, what does that include? Adults, subadults, or a single nested location. So these groups may have been around because of predation, so to avoid predators, which is quite interesting. And there has been a lot of research just because we have so much research into their different animals. There is potentially some evidence of sexual dimorphism for both species, which is quite interesting, looking into it. So they actually looked at different skulls and tried to find difference between the sexes, and females were potentially more characterized by lack of well-developed horns, and then looking back they were kind of like, no, you can't really tell this. And they have been able to know it because of so many individuals who have been noticed different things. But some of them could potentially be, male-female traits, but we really just can't know. In 2020, there's been some evidence to suggest, and there's no evidence to suggest that they were sexually dimorphic, and they may have just varied a lot between morphology and individuals and things like that. But it seems like at least their frill was very important for socializing, or something that would have been selection for potential mates. Good for signaling social behavior is quite as well. In looking into their kind of reproduction, they would have read a lot like potentially crocodiles, ratites, and megapodes, and there has been some potential evidence of parental care. So these guys would have been nesting in the same area together, and they would have made little crater nest, very similar to other ornithischian dinosaurs like Maiasaura. And we do have lots of little babies, which is quite cute as well. And we do have evidence, as mentioned, as predator-prey interactions. We have the fighting dinos with the Protoceratops and Velociraptor fighting each other, which is quite interesting. but we know they probably would have been preyed as well, and evidence due to their cycloric rings they may have potentially had a nocturnal lifestyle, and they're usually a large eyeball, which is interesting. And if you look at birds, that actually suggests these guys may be more nocturnal, but really they just might have needed more light. And then they would have, if it was no animal, it might have a much smaller cycloric ring. But they also looked at that as well and suggested that these guys may have just been, carmothermal, just active whenever. And they were counterthermal, so kind of acted whenever, and they may have been around daylight hours or low light conditions, especially when that interaction may have been happening. The Velociraptor was typically nocturnal. They were just active whenever, or they just slept and then have it. Most large herbivores are carthermal, which means you just come out at different times during the day. It doesn't really matter. But yeah, quite interesting. We do have a lot of an idea of what Protoceratops lived with as well, in the Baharamadadu formation, and we lived with animals such as Velociraptor and Ornithoraptor in a very kind of like sandstone, steamed and wind-deposited sediments. There would have been rivers and things like that, kind of a semi-arid climate. Animals such as Hyracotherium, Pinacosaurus, Dakotaraptor, lots of turtles and mammals, ornithoraptorids, oviraptorosaurs, such as Machinosaurus and Tanglong. Very interesting assortment of animals. And the Dinosaur formation, which is a little bit younger, about 71 to 75 million years ago, they would have lived with animals like Halscaraptor, Oviraptor, Minotaurosaurus, Sidipati, Shuvia, Ichthyovenator, Udamceratops, lots of really interesting animals. And the relatively low paleodiversity and small size of these dinosaurs suggests that these guys would have lived in stress environments, so not many large animals could probably survive in there just because there's not enough food. But also pre-Androsauria was actually predominantly found in this formation. There have been some remains found in the Dishapot formation of Hyracotherium, but these guys may have been preferred more fluvial soil, so may have been preferred like a little bit more warmer and arid conditions, things like that. So there would have been potentially niche partitioning between the two species, and so this other species as well might have just lived a little bit area. So the Baharamadadu formation is the one that contains Hyracotherium, and the Dishapot formation has Androsauria in it. But yeah, quite cool. Definitely very interesting. We have lots of specimens, lots and lots. But yeah, it's cool that we know so much about a bunch of dead animals, and it's cool that we are able to discuss these things and learn so much. We have so many good specimens. We know how they grew and how they died and what they were eating. It's very rare we actually get that good of a look into extinct animals. And we know the two different species and know why they were living and how they avoided each other. But yeah, that was a really cool one. We let them all run off and do their thing. Really awesome job, Hockel1215, always killing it. So yeah, I think this is a great place to end the video, so I really hope you guys everyone enjoyed this video. Hope you guys like and subscribe. Always remember to hit the little bell icon to get notified about anything. So yeah, if you guys enjoyed this video, hope you guys like and subscribe, and bye.